In our last example here, example 5, we have a joint density function f of y1, y2 equals e to the negative y2. And our region here, both y1 and y2 go from 0 to infinity. So let me set up my axes and I'll try to draw that. There's y1 always on the horizontal axis, y2 always on the vertical axis. They both start at 0. Now the catch here is that y2 is always bigger than y1. So let me draw the line y1 equals y2, or y equals x. And we want y2 bigger than y1, which means we want the region above this line. So let me color in that region above this line. Of course, it goes on to infinity, so I'm not going to draw all of it, but that's the general shape. It's this triangular region. And what we want to do is find the marginal density function, f1 of y1. Let me remind you of the definition of marginal density. f1 of y1, I gave you the formula for this back on the third slide to this lecture. There's this variable switch where you always integrate over the other variable. So it's the integral over y2 of the joint density function, f of y1, y2, dy2. And now I need to describe that region in terms of y2, which means, so I can set up my limits on the integral. So I want to think about what the limits would be on that region in terms of y2. So y2, that means I'm going to go take a vertical arrow here. y2 grows up from that line and it goes on, well, it goes on to infinity, doesn't it? So there's infinity. And there's the line y2 equals y1. So my region can be described as y2 goes from the diagonal line y1 up to infinity. So those are the bounds on my integral. y2 equals y1 to y2 goes to infinity. And my joint density function is just e to the negative y2, and I'm integrating with respect to y2. Now, the integral of e to the negative y2 with respect to y2 is negative e to the negative y2. I did a little u substitution in my head to get that integral, and I want to evaluate that from y2 equals y1 to y2. Take the limit as it goes to infinity. And now if I plug in infinity, that's e to the negative infinity, which means 1 divided by e to the infinity. 1 over infinity is just 0 minus negative e to the negative y1, because I plugged in y2 equals y1. And so that simplifies down to e to the negative y1. Let me remind you what we were calculating here, f1 of y1, so the marginal density function of y1. And it is kind of reassuring here that when we calculate that, we get a function of y1. That is what we should get when we calculate a marginal density function. So that is our answer. Let me recap the steps on this. First, I tried to graph this region. y1 and y2 both go from 0 to infinity, but we're only looking at the region where y2 is bigger than y1, so that's why we have this upper triangular region here, all the region above the line y equals x there. And then to find the marginal density function for y1, we have to integrate over y2. There's always this variable switch that's always very confusing. So in order to find the region of integration, I tried to describe that region in terms of y2. So the lower bound for y2 is this diagonal line. That's where I got this y2 equals y1. Upper bound, it goes on forever, so that's why there's an infinity there. And then I plug those in and I get this region of integration. And the density function just comes from the stem of the problem, e to the negative y2. Integrate that with respect to y2. Did a little u substitution in my head, u equals negative y2. Came up with negative e to the negative y2. And then I plugged in y2. Well, the limit as it goes to infinity, that just takes you to 0. And y2 equals y1 gives me my y1 and the exponent. And it simplifies down to this nice function of y1, which is appropriate because we should get a function of y1 when we're looking for the marginal density function of y1. I really want you to understand this example because we are going to use this example again for calculating some conditional and expected probability in the next lecture. I think this example is set to be example 5 in the next lecture. So we're going to use the answer to this example in the next lecture, which is on conditional probability and conditional expectation. Conditional probability. So you'll see this coming back, so I want to make sure you understand this now so that when we drop the answer in, you won't be confused by it in the next lecture. Probability. So make sure that everything's good with this example, and in the meantime, that wraps up this lecture on marginal probability. As I mentioned at the beginning, marginal probability is really a tool in the service of conditional probability. So you'll see a lot of this stuff used in the next lecture on conditional probability and conditional expectation. I really hope you'll stick around for this. These are part of a larger series of lectures on probability here on Educator.com. My name is Will Murray. Thanks for joining us today. Bye-bye.